In this recording, we're going to examine geometric sequences. So, as we mentioned before, a geometric sequence is just like an arithmetic sequence, except we multiply to get from term to term. It has a multiplicative constant. We call this thing R, the common ratio. We call it R. Okay? So we need to know the first term, and then we can get more terms by multiplying by that R. That's written with function notation, and then with subscript notation. Oops. If we have the first term, a sub 1, we can find more terms by multiplying the previous term. Remember, we call that a sub n minus 1, the previous term, by r. So why don't you try exercise 5, try to figure out the next 3 terms using your knowledge, and then play the recording to get the answers. So hopefully work these out, and you can just play and see if it makes sense. So the first term is 4, r is 2, we're multiplying by 2 each time. Do we need to show all that work? Not necessarily. You can just state the terms. That's fine. Okay, to get the second term, f of 2. Well, we know the first term is 9, and we can see that we can get more terms by taking the previous term. When you see this, just think of this as the previous term. Multiplying that by a third. So you can see each term is 1/3 the size of the previous term. So we're exposing you to several different notations here. So this is using t sub n. Is found by taking the previous terms times the square root of 2. Okay, so there we have the second, third, and fourth terms of that sequence. All right. Okay, now we're going to find or discover a formula for the explicit formula for a geometric sequence. In other words, if I want to jump to the 10th term, I don't want to have to find all the terms in between. Right? I know the first term. I can see the common ratio is 3. Do I really have to work them all out, or could I just jump to the 10th term? Well, we can. We just have to discover it. So let's first find the value of a sub 4. Because this is defined recursively, okay, it's defined in terms of the previous term. We have to do a sub 2, a sub 3, and a sub 4. But that's not bad, right? We're starting with 2, and it's saying take your previous term times 3. So it'd just be, okay, so it's just 2 is our starting point, times 3, 6, times 3 is 18, times 3 is 54. All right, how many times do we need to multiply 2 by 3 in order to get a sub 4? Well, we get our 2, our 6, and our 18, and our 54. So just imagine that for a second. So there were 3 multiplications. We had a starting value and 3 increments. So we multiplied 2 by 3 times. Not 4 times, right? We talked about that Monopoly example. That's really important. Let's just note again that it was not multiplied 4 times. Okay, so that's one to avoid. Now finally, the value of the 10th term. Well, if we multiplied by 3 times to get the 4th term, 1 less, right? It follows that we'd multiply by 3 9 times to get to the 10th term, 1 less, because we already got the starting point. That's a sub 1, which I can just put in here as a 2, right? Then we're going to multiply by 3. How many times? Well, 1 less, and multiplying by 3 many times involves an exponent, right? So it's 9 here. So then you just work out that. Turns out it's 39,366. Here we make a little note, 1 less than the term number. So finally, our formula, our explicit formula, and the advantage of an explicit formula is that it allows us to jump to any term we want. The 500th term, although that would grow pretty quick because we're multiplying by 3. You're going to take your first term, okay, kind of like we took our 2, and you're going to multiply by that common ratio, r. How many times? Well, it's always going to be 1 less than the term number you want to find, and so our exponent is going to be n minus 1. Thanks for watching.